Hello everyone, my name is Nicole Ernst and I teach Geospatial Technology at Harrisburg Area Community College. One of the classes I teach is called Data Acquisition and Remote Sensing, and students learn how to find and model GIS data in this class, and they also learn how to find and utilize satellite imagery and aerial photographs. In this module that I'm going to be developing for this experience, I'm going to be using remote sensing to identify where Mayan ruins might be found. Before I get into the details of what we're going to be doing, just to give you an overview of what remote sensing is, it's essentially obtaining information about an object, area, or phenomena without being in direct contact with that object, area, or phenomena. So you're not physically in touch with it. So you can think of this as airborne and spaceborne platforms that are using electromagnetic sensors to collect data. One very well-known remote sensing program is the Landsat missions that are a dual project of NASA and the USGS. Landsat has been in operation since 1972, and since 1972 we have continuous coverage of the Earth's surface on a 16-day cycle, which is really cool. It's moderate resolution data. Each pixel is 30 meters by 30 meters, so it's not the most crisp images, but it still helps us to look at change over time. So because this has been in operation since 1972, we have over 40 years of continuous coverage. Right now, we are lucky enough to have two Landsat missions that are up in space, Landsat 7 and Landsat 8. Because the repeat cycle for one of the satellites is 16 days, having two up means that we have a repeat cycle of every 8 days. So imagine today where we're sitting, we're getting coverage. 8 days later, the satellite will be back collecting data for this very same point on the Earth's surface. The reason why we're going to be using Landsat data for this particular study is so that we're able to see in other areas of the electromagnetic spectrum that humans can't see in. The humans can see in the, what's called the visible portion of the electromagnetic spectrum, and that portion runs from 4 micrometers to 0.7 micrometers, so very, very tiny little section. So if you conceptualize the electromagnetic spectrum as a continuum that runs from New York City to Los Angeles, the size of the visible portion of the electromagnetic spectrum, that which humans can see, is only the size of a dime. And so that's pretty amazing. So Landsat data helps us see outside of that visible portion of the spectrum. So it opens up kind of a whole new world of, and a whole new way of looking at phenomena and objects. So my particular objectives with this module, the main one is to use Landsat imagery to acquire the digital signature of the Mayan ruins. The Mayan ruins are essentially constructed out of limestone, and it has a definite digital signature attached to it. By grabbing that digital signature, we can then apply that to other images to pull out areas where we might find some Mayan ruins. So the first objective is going to be to explore the geology and geography of the Yucatan Peninsula, so students have a background of the history, the culture, and so forth. And this is going to be a little bit more laid out as I go along, but essentially students are going to be finding data, aggregating it into GIS data so that they can produce maps so that they can gain a geographic understanding of the area. So the first thing that they would be doing is finding a geology map that shows the lithology of the geology, so that they learn that, hey, this is a really heavy limestone region, and that's something that's obviously important to the whole thing, is just knowing what the geology is and where else that geology might be found. Students will then find data for where all the Mayan sites have been identified and located, and they'll make just a very basic map like this showing where the sites are. From this, what it really tells you is how clustered they can be, or how distributed they can be. So you can kind of see where the civilization might have been more dense. That then gets turned into a density map, and we can see up in the northern part of the Yucatan Peninsula, we definitely see a higher concentration of Mayan sites. And as we go on, they're going to kind of correlate that with even the timeline of the Mayans and how they started. They started kind of further south and slowly started moving more north. So that's the first part, is just to kind of have that just general background and understanding of the Mayas, so that they kind of have the reason why we're looking for them in mind. So next, what we would have to do is identify what Landsat images we have to use, download the appropriate images, create color composites, and then perform the classification. So all the fun techie stuff is what comes next. So in order to find the Mayan, the appropriate Landsat images, there's actually a grid that was developed by USGS and NASA that each one of these squares is a satellite image, and each one is identified by a path and row. So students would download any of the boxes that overlap the Yucatan Peninsula, and then they would go to Earth Explorer, which is the repository for an archive for Landsat images, and they would find an appropriate image for the study, which is actually pretty time consuming, because they have to think about things like how much cloud cover is there, because you can't really use cloud covered days, because that impacts what we can see. Or if there were any calibration issues with the sensor at the time, there might be banding on the images or some other wackiness that might happen. So it takes a while to sift through them, and in theory it would be really nice for all the images to be taken on the same day, but finding a completely cloud cover free Yucatan has proved to be very difficult, so it will likely be different days that are used. After the data is found and downloaded, all what you see right here is just one image, and it's like band 1, band 2, all the various bands of data that are collected. Students then have to process them to create color composites. So this is a true color composite, rendering it using bands 4, 3, and 2. This is a near infrared composite, and then we have a shortwave composite. And the reason why we render these differently is because each rendering allows us to see different things or accentuates different features on the map. For instance, if we look at the very first one, there's some water bodies down here, but notice how they pop just a lot more using the near infrared rendering. So they start playing with those band combinations to kind of look at features in a little bit of a different way. After they create the color composites, they then will do an image classification. Essentially, they are categorizing the pixels in the images to correlate to some actual category or class. So they might, like in this area here, that you draw a little polygon to represent water, and you get a few different training sites. Like in here, grab something that's water, and then you might do agriculture, urban, and then what it produces back is a category map showing the classes of the various land use. So for this one, we would actually be just really looking at what is limestone. So we would just get a lot of limestone, do a lot of limestone training sites, so that it's able to pull out the limestone areas, and then we would have a map showing that, and those areas would be places for potential Mayan ruin locations. One of the things that I'm going to be doing when we're down there is I'm bringing my handy GPS along, so that I can actually collect training sites for students, so that they can do a comparison of using actual ground truth data versus what they picked out on the images, them thinking it was limestone geology, and then they can do a comparison of that. So that, in a nutshell, is the module that I'll be doing, with lots of little things kind of pulled in there. This is going to probably likely be used for a final project, so that they have time to kind of go through this and just build on the whole project. So if you have any questions or have any feedback, I'm happy to take questions and feedback, and I look forward to continuing working on this project.